Inverse trig functions. If I give you the function f of x equals sine x, what's its inverse?
Arc sine.
Nope. Give you a hint, it was a trick question.
Oh, yeah, it doesn't have one.
It does not have an inverse. How come it does not have an inverse? It is not a one-to-one function.
If we found it, is it then arc sine?
That's exactly what we're going to have to do. What we're going to have to do is we're going to have to limit its domain to force it to be one-to-one, and then we will call its inverse arc sine. All right, so consider your sine graph here for a minute. Your sine graph looks something like this, of course. So what we want to do is we want to pick a domain for the sine graph so that the function will be one-to-one, and we also want to capture all of the possible y values that we can. So we want to make sure that we use all the y values between -1 and 1. So how do we limit our domain to force the function to be one-to-one and capture all the y values? We start right here at -pi halves, comma -1, and we go to here, which is pi halves, comma 1. That's the commonly used restriction of the domain. Is it the only restriction you could use? No, I mean, we could go from here to there, and we could choose that to be our domain. Why do we choose this one?
It's convenient.
It's convenient. Mostly it's convenient because angles between 0 and pi over 2 are in quadrant 1, and we really prefer to use angles in quadrant 1 whenever we can. Okay, so we're going to have this function, f of x equals sine x, and we're going to limit the domain to be between pi over 2, and of course its range is between -1 and 1. Once we have the domain limited and we have a one-to-one function, we can then talk about its inverse. G of x is arc sine of x. For arc sine, what would be the domain? What kind of x numbers can I plug in? I can plug in x numbers between -1 and 1. Because remember what the inverse does. The inverse interchanges the x's and the y's. So if the y's on my sine function go between -1 and 1, that means the x's on my inverse function go between -1 and 1. And when I plug in numbers between -1 and 1 into arc sine, what kind of answers am I going to get out? I'm going to get angles that live between -pi over 2 and pi over 2.
What would the graph of that look like?
What would the graph of that look like? That's an excellent question. Anybody got an answer?
Right?
I would draw the line y equals x, which would look something like this, I think, and it would flip over that axis. So I think it's going to look something like that. We could grab our calculator and have it graph arc sine if we want to, but I think it's going to look something like that. All right, so the first kind of questions I'm going to ask you. What's the arc sine of 1/2? That's exactly the same question as asking you sine of what gives you 1/2. That's right. So the sine of what gives you a half? What's that?
Inverse 1/2.
Remember that chart that I wrote up here on the board that you went home and you memorized? sine of pi over 6 gives you a half? Not pi over 3?
Guys, I wrote this wrong.
See, that's one of my favorite tricks in the world is I can almost always convince people that they have the wrong answer when they do have the right answer. Pi over 6 was the right answer. One of the mean math teacher tricks there. Have people give you the right answer and convince them they're wrong anyway. Pi over 6 is the right answer. All right, how about the arc sine of negative square root of 2 over 2? Pi fourths is almost the right answer.
Negative 5/4.
Negative pi fourths. Why negative pi fourths?
It's negative.
Because this is a negative here, so I'm asking you sine of what would give you negative pi over 4. The answer, or I'm sorry, gives you negative square root of 2 over 2. I look on my chart, it looks like pi over 4 is the right angle, except for this minus sign. My angle has to be in quadrant 4 because sine is negative in quadrant 4. What's the arc sine of pi over 2? What do you know?
Happen in that closet.
Can't happen?
No, it can't,
It can happen. Okay.
because it's that point right there, right?
I would say no.
You would say no to what?
I don't know. Like,
It's not in
it's
your domain.
It's the right.
Is undefined is the correct answer. Pi over 2. Pi is about 3.14. So 3.14 divided by 2, that's a number bigger than 1, isn't it? Can I plug a number bigger than 1 into this arc sine formula? No, I cannot. So the answer is undefined. If I had asked you arc sine of 1, then you would have told me arc sine of 1 is pi over 2. That's correct. All right, so watch out for that. Very, very tricky, your domain issues. The only numbers you can plug into arc sine are numbers between negative 1 and positive 1. I cannot plug in pi over 2. Not within the domain. All right, how about if we talk about the function f of x equals cosine x? Is that function 1 to 1? No, so it does not have an inverse either, so we've got to do the exact same trick. We have to limit its domain. Our cosine graph looks something like this. Notice I cannot use negative pi over 2 to pi over 2 because negative pi over 2 would be here. Pi over 2 would be there. That function would still not be 1 to 1 because it would fail the horizontal line test. So I don't get to use the same domain. I don't get to use negative pi over 2 to pi over 2. What domain do I have to use?
0 to pi.
0 to pi. We're going to go from right here, which has the point 0, comma 1, to right here, which has the point pi, comma negative 1. And then our function between those 2 points is 1 to 1. And we get all the y values. We get a high value of y equals 1, a low value of y equals negative 1. So for cosine x, we have to have 0 less than or equal to x less than or equal to pi. And our y values are still between negative 1 and 1. I can now talk about g of x, which is arc cosine of x. Once again, the domain will be numbers between negative 1 and 1, but the range are going to be angles between 0 and pi. So there's the first thing that makes inverse trig functions very difficult. Depending on which function you're talking about, you have different domains and ranges. And that's confusing. You got to remember which domain and range goes with which of the functions. All right, so how about the arc cosine of 1/2. So what I'm really asking you is, cosine of what gives you an answer of 1/2? You go to that big chart that you've memorized and you look it up, and the answer is 5/3? 5/3. How about the arc cosine of negative square root of 2/2? Negative pi over 4 is not the right answer. Because you're just kidding. I thought you were just kidding.
Root 2/2.
Because when you're dealing with arc cosine, your angles have to be positive numbers. Your arc cosine angle cannot be negative pi over 4. So again, this is where inverse trig functions get confusing. If I had given you arc sine of negative square root of 2/2, that one was negative pi over 4. Negative pi over 4 cannot be the right answer for arc cosine, however. It's not in the appropriate domain or range. So what is the right answer? All right, so keep in mind, when we're dealing with arc cosine, we're using what kind of angles? Positive between 0 and pi. All right, so we're using angles in quadrant 1 and quadrant 2. I know the answer has to be something with a pi over 4, because I looked on that big table that I memorized, and I saw that the cosine of pi over 4 was square root of 2/2. So what I need is the angle in quadrant 2, which has pi over 4 as a reference angle, which means that this angle right here is pi over 4. If that angle is pi over 4, what's that angle? Because it would be halfway around would be pi, and then we subtract the pi over 4, which is 3 pi over 4. So the answer is 3 pi over 4. The moral of the story is arc cosine is a lot harder to work with than arc sine. Arc sine is easy. You look at the table, it's either the positive thing on the table or it's the negative thing on the table because of the angles you're allowed to use for arc sine. For arc cosine, when you have negative numbers in here, it becomes a pain in the neck because you've got to find your reference angle, then you've got to convert everything to quadrant number 3. Questions on that? All right, so let's do another one. How about arc cosine of negative 1/2? Well, it's pretty much the same deal. We know the reference angle is what? Pi over 3, because up above we have arc cosine of 1/2 is pi over 3. So we need to take the angle pi over 3, and we need to find its equivalent angle, but the angle needs to live in quadrant 2. So how do I find the angle in quadrant 2 that has a reference angle of pi over 3? Now, how did I do it for the problem up above? I took pi minus the reference angle. So that's what you're going to have to do. For arc cosine, when you're dealing with negative numbers, it's always going to be pi minus the reference angle. That will always give you the angle in quadrant 2. Get common denominators and subtract, that's 2 pi over 3. Questions on that? All right, so like I say, arc cosine is more difficult to deal with than arc sine, just because of the way the domain and range have to work out. All right, well now let's have some fun. How about if I gave you the sine of the arc sine of 3/8? What's the sine of the arc sine of 3/8? 3/8. How come?
Because they cancel each other.
It's because sine and arc sine are inverses, so they cancel each other out. The answer is 3/8. Okay. How about the cosine of the cosine inverse of negative 5/12? What's the cosine of the cosine inverse of negative 5/12?
Negative 5/12.
Why is it negative 5/12?
Cosine, inverse cosine, cross out.
Cosine and inverse cosine are inverses. The answer is negative 5/12. Boy, these are easy. I like these. Let's do some more of these. All right. How about the sine of the arc sine of 4?
Can't do it.
Can't do it. Why not?
Outside of the domain and range.
Can I take the number 4 and plug it into arc sine? No. Why not? Because he said it. It's not in the domain and range. So what's the answer? Undefined. So those look easy at first, but you do have to watch out for those trick questions. It's very, very easy to say sine and arc sine cancel each other out. The answer is 4. And that's not the right answer. Can't be 4. 4 is not the domain and range of the appropriate functions. All right, how about if I flip things around? How about the arc sine of the sine of pi over 6? Pi over 6, how come?
Inverse.
They're inverses, and pi over 6 is within the usable domain. So that's pi over 6. All right, that was an easy one. I like that one. How about the arc sine of the sine of 2 pi over 3? Can't do it? I can do it.
What's the, have the reference angle for pi over?
All right, so I can do it, but the answer is not 2 pi over 3. How come the answer cannot be 2 pi over 3? 2 pi over 3 is outside of the acceptable range of arc sine. So here's what you have to do with this one. You actually have to work out the sine of 2 pi over 3. What's the sine of 2 pi over 3? Okay, let me ask you another question. In which quadrant is the angle 2 pi over 3? Second quadrant? You didn't say that with confidence. Oh, you did say it with confidence?
No.
So why is 2 pi over 3 in quadrant number 2?
It's greater than, pi over 2.
It is bigger than pi over 2, and it's a little bit less than
Pi.
pi. So in quadrant number 2, sine is a positive number, isn't it? So I have sine of something. This is going to be positive, and then I need to do the arc sine. So basically what I need is I need the angle in quadrant number 1, which is equivalent to the angle 2 pi over 3. I need the angle that has the reference angle, basically. So what's the reference angle for 2 pi over 3? Pi over 3. So what's the answer? Pi over 3.
But you couldn't do it if it was the other way around.
If it were the other way around, I could... actually, I could do it if it was the other way around. No, I couldn't, because 2 pi over 3 would be bigger than 1.
Yeah.
So I would not be able to do the arc sine of that first number. That's correct. All right, one more of these. How about the arc sine of the sine of 5 pi over 4? First off, the answer cannot be 5 pi over 4. How come the answer cannot be 5 pi over 4? It's not in the appropriate range, that's correct. All right, so we got to think of this angle 5 pi over 4. Where is this angle 5 pi over 4? It's in quadrant 3. In quadrant 3, sine is negative. So when I do the arc sine, since I'm doing the arc sine of a negative number, I'm going to get an answer in quadrant number, where is sine negative? Quadrants 3 and 4, but my acceptable range for arc sine only uses quadrants 1 and 4. So the answer has to be in quadrant number 4. It's got to be written as a negative answer, and then it would simply be the reference angle for 5 pi over 4. Negative pi over 4.
So can you just take the reference angle in almost every case and subtract it from pi? Because if you did that, you would get pi over 4 in most of these cases.
No. Would you like an example?
No, I believe you.
Too bad, you're getting an example. Arc sine of the sine of 11 pi over 6. Not pi over 6, but you're close. Why negative pi over 6? Because 11 pi over 6 is just a little bit smaller than 12 pi over 6, which would be 2 pi. So 11 pi over 6 is in quadrant number 4. So when I do the arc sine of the sine, I need the answer in quadrant number 4, but we have to write it as negative pi over 6 to have it be within the appropriate domain and range of the appropriate functions that we're using.
Or actually, you're just taking away the root of 5 and the 11. And negative or something.
That is true. So what really is happening is you're taking away the 2, the 5, and the 11, and then you just have to decide, is it a positive answer or a negative answer?
What quadrant it's in.
Which quadrant it's in. That's correct.
That's it?
That's it.
That's correct. All right.
For sine. But what was the bad news I told you about cosine?
Cosine can only be positive.
Cosine is harder because cosine you just don't get to do positives and negatives. You got to deal with quadrants 1 and 2. All right, so let's do some cosine problems. How about, which way do you want me to start? Do you want me to put cosines first or arc cosines first?
Does it make a difference?
It's a huge difference.
So arc cosine.
Let's go arc cosine. So we want the arc cosine of the cosine of, give me an angle that you like.
13 pi. 13 pi over 3.
13 pi over 3. You got it. Made it hard, but you got it. All right. So the first thing we need to decide, we need to figure out in which quadrant is 13 pi over 3.
It should be in the first, shouldn't it?
I don't know.
Yeah.
Because it'll have gone through all 4 quadrants worth of things and got back to the first quadrant.
All right. So
2 pi, 30, and there's
13 over 3 is 4 1/3.
Yeah.
So let's see. 2 pi would be 1 rotation. 4 pi would be 2 rotations. So 4 1/3 pi would be just past
Yeah.
the axis. It would be in quadrant number 1. All right. So since this is in quadrant number 1, we need the angle in quadrant number 1, which has this as a reference angle. Pi over 3. The answer is pi over 3.
Good.
Yeah, the answer is pi over 3.
I think if we had like 10 might be, no, 10 would work.
All right, well, we don't need to make it that hard.
Yeah.
Let's just do the arc cosine of the cosine of minus pi over 4. If I were dealing with arc sine and sine, the answer would be very, very simple. The answer would be Negative pi over 4, because negative pi over 4 is in the appropriate domain and range of the sine and the arc sine function. Pi over 4 is not the right answer here, though. So what is the right answer?
Alright.
Pi over 4 is the right answer?
Yeah. So it was probably something.
Convince me that pi over 4 is the right answer.
No.
I wrote it down. That's convincing enough, right? No.
Yeah.
All right. So where is the angle negative pi over 4? Which quadrant? Second, fourth, third. That's right. It's in one of those three. I'll give you that.
It's in the fourth.
It's in the fourth, right? Negative pi over 4 would be that angle right there. So that is in quadrant 4. What can you tell me about cosine in quadrant number 4? It's positive. So when we want to deal with the arc cosine is positive in quadrant number 1, so we need the answer in quadrant number 1. The answer in quadrant number 1 is positive pi over 4. That's correct. All right, so that one was easy. How about the arc cosine of the cosine of 7 pi over 6.
Pi over 6.
What's that?
Pi over 6.
You'll go with pi over 6?
Yep.
Yeah.
Convince me it's pi over 6.
One. No,
Pi over 6 is the wrong answer, by the way.
yeah, no, but that's in the second quadrant, isn't it?
Okay, so first question is,
Pi over 6.
where is the angle 7 pi over 6? It's in the third quadrant because 7 over 6 is just a little bit bigger than 1, so it's just a little bit bigger than pi. So this is in quadrant number 3. 7 pi over 6. In quadrant number 3, cosine is negative. So when I use arc cosine of a negative number, I have to get an answer that's in quadrant number, not 4. Cosine is positive in quadrant number 4. 2. Cosine is negative in 2 and 4, in 2 and 3, I mean. But when we're dealing with arc cosine, remember, we only use angles between 0 and pi. So our original angle is 7 pi over 6, which has a reference angle of, what's this little angle down here? The reference angle is pi over 6. However, the angle that I really need is the angle in quadrant 2, which has pi over 6 as a reference angle. It's pi minus pi over 6, which turns out to be 5 pi over 6. So arc cosines are lots of fun. You're chasing around all sorts of quadrants. This is in quadrant 3, so I need an answer in quadrant 2. I've got to find my reference angle, which is in quadrant 1.
Is it always over the x-axis?
What's that?
Is it always over the...
Reference angles are always drawn to the x-axis, yes. Always, always, always.
So why do we deal in the first quadrant for the last reference angle?
Well, the reference angle would be pi over 6, which is an angle over here in the first quadrant. But I usually tend to draw it here and there as my reference angle.
But I guess why is it for 5?
Why is it 5 pi over 6? Because this reference angle here is pi over 6. So the angle that I need is this one.
Why? I guess that's my question.
Because I got to have an answer in quadrant number 2. Because this value right here, this is a negative number. And so when I'm dealing with arc cosine of a negative number, my answer has to be in quadrant number 2. Cosine is negative in quadrants 1 and 2. Since I'm dealing with a negative, I have to live in quadrant 2. Because arc cosine only uses angles between 0 and pi. It uses quadrant 1 and quadrant 2. So it had to be pi minus pi over 6, which turns out to be 5 pi over 6. Other questions?
What can we use this for?
Well, we're getting there.
Okay.
We're getting there. We haven't done any calculus yet, have we? I haven't seen any derivative or any integral yet. Those are coming, and we'll start using these for derivatives and integrals. But before we do that, how about the sine of the arc sine of x over 3? What's the sine of the arc sine of x over 3?
I don't know what actually.
Okay, it does depend on what x is. Whenever I use the letter x in one of these problems, we're going to assume that x falls into the domain that we need it to fall into. In this case, x would need to be between -3 and +3. But whenever you use the letter x, it's just assumed that x is in the appropriate domain.
So it's just X over 3.
So it would just be x over 3. They would cancel each other out, correct?
Will that domain still be attached to it?
Yes, the domain would still be attached to it. X would have to be between -1 and -3 and +3.
Write that outside or something?
Usually we don't.
It's
just
assume.
Assume that we know. All right, so that one was easy. What about the sine of the arc cosine of x over 3?
Domain would be, wouldn't the domain get further restricted?
I think the domain would still be the same. X would have to be between -3 and +3 because I need this to be between -1 and +1. But I don't just get to cancel these out, do I? Rats. What do I do?
Well, what is it? It's like, sine is equivalent to like 1 minus cosine squared or something.
True. I don't think that helps. Sine squared plus cosine squared is 1. You're using that Pythagorean identity. I don't think that helps. All right, well, what does arc cosine do? Arc cosine takes a number, and it gives you what back? An angle. So this is sine of some angle theta. I don't know what the angle is yet. But I do know that theta is the arc cosine of x over 3, correct? I'm going to take this equation right here, and I'm going to apply the cosine function on both sides. On the left-hand side, I get cosine of theta, and on the right-hand side, I get x over 3. I'm going to draw a pretty little triangle. Pretty little right triangle. Here's my angle theta. If that's the angle theta, and cosine of theta is x over 3, cosine is adjacent over hypotenuse. And then I can go talk to my good friend Pythagoras and find the length of the other side. A squared plus b squared equals c squared. Work that out. You'll get the square root of 9 minus x squared. So now using this triangle, I can come back up here. Sine of theta. Here's my triangle. Here's my theta. How do I find sine? Opposite over hypotenuse. So the answer is the square root of 9 minus x squared over 3. You hate trig. You better learn to like it. Because there's a lot of trig in this section. There's a lot of trig in the next chapter. There's a lot of trig in this course. There's no way around it. All right, let's try one more of those. How about the cosine of the arc sine of, give me something with an x in it.
2x over 5.
2x over 5. I like 2x over 5. That's good.
But we could have just used x and then we got this big 1.
That's true. We could have just used x. It would have been easier. We decided to go nuts. We're going to use 2x over 5. All right, so it's the exact same deal. The exact same deal is, this is cosine of some angle theta.
You can call it theta substitution.
It's a theta substitution, if you will. We know that theta is this arc sine of 2x over 5. I'm going to take this equation and apply the sine function on both sides. That'll give me sine of theta is 2x over 5. I draw my triangle. Here's my angle theta. How do I label this triangle? Opposite is 2x. Hypotenuse is 5. You'll let me do the Pythagorean theorem, okay? When I do the Pythagorean theorem, I'm going to square that one, I'm going to square that one, and I'm going to subtract them. So that's 25 minus 4x squared. You'll take my word for it, thank you. All right, so our final answer is, cosine of that angle will be square root of 25 minus 4x squared all over 5.
That's the answer.
That's the answer. All right, so now we're ready to do some calculus. All that work to get to the calculus stuff. Yeah, we got 5 minutes to do calculus. Let's say I let y be the function arcsine of x, and I want to find its derivative.
Ln.
Not ln, but you're on the right track. ln doesn't get rid of an arcsine. What gets rid of an arcsine?
Sine both sides.
A sine. So I'm going to apply the sine function on both sides. I get
Sine y
sine of y equals
equals x.
x.
So it's just the inverse of sine x.
It's the inverse of y equals arcsine x. That's right. Sine y equals x is the inverse. I take the derivative. What's the derivative of sine y? Cosine y dy dx equals 1. The derivative of x is 1. So that gives me dy dx is 1 over the cosine of y. But that's not a very satisfying answer, because normally when I start with y equals something with x's in it, when I take its derivative, I want its derivative to be something with x's in it. I don't want y's there. So I'm going to fix that. That's 1 over the cosine of the arc sine of x. Which is a perfectly nice answer, but we're going to simplify it. So how do I simplify the cosine of the arc sine of x? I'm going to do just like I was doing a few minutes ago. I'm going to call that cosine of theta. And what can you tell me about theta? Theta is the arc sine of x. Apply sine on both sides of that. Sine of theta equals x. So that's why I didn't just pick x before, because I knew we were going to do this one anyway. I draw my triangle. There's theta. It's a right triangle. Opposite over hypotenuse would be 1. Think of x as being x over 1. Pythagorean theorem. This side is square root of 1 minus x squared. So what can I say about the cosine of the arc sine of x? It's equal to the cosine of theta, which is going to be square root of 1 minus x squared over 1. So we come back up here. Here's our formula for derivative of arc sine. The derivative of arc sine turns out to be 1 over the square root of 1 minus x squared. So do you see?
Nice and made it out of 1.
What's that?
You're nice and made x and not like x over 2 or something.
Well, no, we always use, the x came from the fact that we used x here. If I now that I have a formula, for derivative, what if I had the arc sine of 2x? How would I take its derivative?
1 over square root 1 minus 4x squared.
Almost correct.
Times
Y times 2.
the derivative.
The derivative of the inside. Oops, you can't see that, can you? You would have to use the chain rule. Okay. All right, I won't work it all out, but I will tell you that the derivative of arc cosine of x is negative 1 divided by square root of 1 minus x squared. Where do you think the negative 1 came from? Well, if you look back up here, we would do the exact same trick, except we would have cosine y equals x. And what happens when you take the derivative of cosine? You get negative sign. That's where the negative comes from. So the formulas for derivative of arc sine and arc cosine are almost exactly the same. The only difference is the derivative of arc cosine has a negative.